Okay, 5.2 is called trigonometric functions. So as a reminder, what we did last week, 5.1 was Thursday, right? We just kind of talked about the angle measurements. We talked about coterminal angles, that kind of stuff. Now we're going to get into like the big word that is SOHCAHTOA. And a lot of the foundation of what we're going to do moving forward is based on that. So if you are moving around your circle, right? And you have an end point that gives you an x and a y. This is your horizontal distance and your vertical distance. So if I actually said that the end point of an angle is at 2, 3, let's say, and I actually drew this on a coordinate grid, so I'm just going to do the x and the y so you can get an idea. I would go right 2, I'd go up 3. And that would be the end of the angle. So this could be here and this would be here. And what happens is we are actually drawing out a right triangle. The 2 would be the change in your horizontal, which would be the x. The 3 would be the change in the vertical, which would be the y. And your angle would go in that little corner where it makes the angle with your x-axis and the end of the angle. So what happens here is we actually have an overlap between your coordinate grid and a right triangle. These are all going to be right triangles, which means that the Pythagorean theorem can be used to find your missing side, and we call this r. It's a radius. And then because the word SOHCAHTOA, it means sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Because that is true, we can actually get these. Sine is y over r, cosine is x over r, tangent is y over x. And then these are called reciprocal functions, and they are the reverse of the first ones, or the reciprocals of the first ones. Cosecant is r over y, secant is r over x. Cotangent is x over y. So you're going to see in a minute like how we apply these, but know that if your brain sees it as a right triangle and you want to use SOHCAHTOA, you can, or you have to like just memorize these. So if you look at the box in the bottom, you'll see that as you move around the circle, if it's positive and positive, if my x is positive and my y is positive, this angle is going to live in my first quadrant. If my x is negative, so this would be negative, this would be positive, now my angle lives in the second quadrant. If they are both negative, so I'm moving left and I'm moving down, the angle is in the third quadrant. And if it's positive x and a negative y, now my angle would end in the fourth quadrant. So all the rules of our x and y still apply like they normally do. You're just moving around your quadrants almost in that circular pattern. So the first thing we're going to do is use the endpoints, okay? These say the terminal side of an angle theta in standard position passes through the point 815. Find the 6 trig values of theta. So by 6 trig values, it means sine of theta. It means cosine of theta. It means tangent of theta. And then the reciprocal, cosecant of theta, secant of theta, and cotangent of theta. Well, that's really hard to see in that color, sorry. So the first thing you want to do is draw out your point. So if I have a terminal side and it's 815, I'm moving to the right move to the right 8, up 15.
Wasn't it yellow to the right of our C?
So the whole column is cosecant, which is CSE, secant, CEC, SEC, sorry, and then cotangent, which is COT.
It seems like because I know the sine, cosine, and tangent are on the calculator.
Yep.
Are the other thing on calculator too?
No, it would be 1 divided by sine, 1 divided, because it's the reciprocal. So if I have to find it on the calculator, I do 1 divided by the reciprocal. So like cosecant and secant and sine go together. So if I said to find the sine of 30 degrees, you'd literally hit sine of 30. But if I hit, say, the cosecant of 30 degrees, you do 1 over the sine of 30 degrees.
Oh.
Which we'll get to, that's more like in 5.3. Okay. There's more right triangle stuff. All right, so we're just doing the triangle for now. So we move to the right 8, we move up 15. I know this is not drawn to scale, but it doesn't really matter. I also need to find, remember this is called R. Do you remember the triple that has 8 and 15? Have we talked about triples? No, we haven't, right? Go back to Pythagorean identity, or Pythagorean triples. You remember these, yes? Yeah. They are 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, 8, 15, 17. So obviously knowing that makes this question easier. If you don't know it, then you've just got to work it out using the Pythagorean theorem. So I would have to do 8 squared plus 15 squared equals r squared. 64 plus 225. R squared would be 289, which is like the most obscure one to know, but it is 17. A squared plus b squared equals c squared. So the c in this case will be the radius. Always the radius. And the radius will always be positive. It's been a long time, right? Yeah. All right, so sine, if you look back on that last slide we just had, sine is y over r. It is also opposite over hypotenuse. So opposite from where theta is 15 and the hypotenuse of that little triangle is 17. Same thing. So this would be 15 over 17.
So is y over r the same thing as O over h?
Yes.
So can we just write over h instead of y over r?
Yes.
Okay. Wait, how do you know that it's O over?
So that's, so the word SOHCAHTOA, which you'll see that more in 5.3, like the way your book does it, it delivers all this stuff on your like circle with your radius, and then it delivers it all in right triangle in the next section. So we'll see it more in the next section. But just know that these are interchangeable. As long as you know the word SOHCAHTOA, right? Then SOH means sine equals opposite over hypotenuse. You remember this from geometry, right? Yeah.
Geometry, but I was wondering how you knew that like y over r was the same thing as like opposite over hypotenuse.
So the opposite theta is 15.
Right.
And then the hypotenuse is always opposite. So the right angle would be here.
So cosine would be like opposite hypotenuse. Alright, yeah.
What's cosine?
The like
CAH, right?
like
Stands
it
for?
was the same thing as A over 2.
So it'd be adjacent.
That's right.
Yeah, adjacent over hypotenuse. Or in terms of this last slide, it's x over r.
And then x over r is the same thing as the adjacent over.
Yes. So they are interchangeable. So this could be 8 over 15. Wow, there's a serious lag. Wait for it.
Is that the answer if you plug it into the calculator?
No, that's the answer. Good question. You'll keep them exact just like that.
So you don't do like sine of 15 over 17?
So if you know the angle, then you hit the sine button on the calculator. Now we don't know the angle, but we have the ratio. So the only thing that would be different is this. If you wanted to find the decimal there, you would actually just divide 15 by 17.
Okay.
You're welcome.
Sorry for another question. So the opposite would be from
The angle's always in that corner where the x-axis would join with the radius of that terminal side. So the angle's always going to be here, 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 or here. So opposite is 15, and then hypotenuse is 17.
and then the other one.
And adjacent is going to be the one next to it, right? The x-axis.
Okay.
So the y is always the opposite, and the x is always the adjacent.
So you're going from the angle that's touching the
Correct.
graph.
That which is like, it's called a reference angle, but yeah, that's that angle.
Okay. So not the right
Oh,
angle.
wouldn't it be
Nope.
8/17?
Oh, yes, 17. Sorry, talking and doing two things at once. 8/17 is x over the radius. Okay, then tangent. So tangent in terms of the y and the r's and all that stuff is is y over x. In terms of SOHCAHTOA, it's opposite over adjacent. So what's opposite theta, or what's the y? 15. And what's the x? 8. Now we go to the next ones, which are the reciprocal functions. So cosecant is the reciprocal of sine, sorry, which means literally take sine and flip it.
Oh, so it means 17 over.
Yep.
So it's
R over y
Or
or h over o. Yep. Secant would be what? Reciprocal of cosine.
Oh,
17 over 8, or r over x, or h over a. Cotangent is the reciprocal of tangent. So 8/15, x over y, or adjacent over opposite. All right, so for 2, we're going to try to do it with the x, the y, the r, just because that's what this section is. But again, it still can be used as SOHCAHTOA. So the terminal side of angle theta in standard position passes through the point -3, -4. So this time, I'm going left 3, down 4, close it in, and theta goes in that little corner where the angle makes with the x-axis. What would be the missing side?
R.
What's the value for r?
Oh.
What's the triple? 3, 4, 5. Again, r always positive. If we don't know it, then I would do -3 squared plus -4 squared. 9 plus 16, that's 25. And that equals r squared, so r equals the square root of 25, which is 5.
Question.
Yep.
You said you always put the little, I don't know, the symbol.
It's a theta.
Theta? That's what you said?
Theta,
It's always the angle closest to the
X-axis. Yep.
Wait, or the center. I mean,
It's the terminal side to the x-axis.
so closest to the origin?
Yep. Well, but closest to because it could technically be the other way. Closest to the x-axis, right? Because the origin is a point, so it could be here or it could be here. You always want it in between the angle and the x-axis, so always closest to the horizontal.
But the right angle is on the x-axis too.
Yeah, but it's over here. Yeah. So this would be my right angle. All right, so let's do in terms of y's and r's and x's. Okay, sine is y over r, which would be good, -4/5. Cosine is y over x. What? Holy moly. X over r. Sorry. So what's that? -3/5. Tangent is y over x. Good. 4/3 would be -4/-3. That simplifies back to positive. And then go straight to your cosecant, which is the reciprocal of sine, -5/4. Secant, which is the reciprocal of cosine, -5/3. And cotangent, which is the reciprocal of tangent, 3/4.
Does it matter like where you put the negative?
Nope. So if there's one negative, it can be in the top, it can be at the front, it could be in the bottom. It just can't be in more than one place. Yep. Questions so far? So again, if you prefer SOHCAHTOA, that's totally fine. Okay? I'm teaching it and focusing on the X's and the R's and all that stuff just because that's what that last slide had and that's how your book goes in order. But if you are better at the right triangle and you want to use SOHCAHTOA, an opposite over adjacent and an opposite over hypotenuse and adjacent over hypotenuse, do that. Okay? It's whatever makes the most sense to you. Alright, so now we're going to think about applying these quadrant angles that we talked about on Friday, or Thursday actually, and finding those trig functions. So look at sine of 90, for example. Okay, that top box is all of 90 degrees. Where's 90 degrees on my circle? At the top. What's the coordinate point there? 0, 1. So what we cannot do, because you're not moving left or right at all, you're just going up. There's no triangle here. We cannot find sine, cosine, and tangent of a 90-degree angle. Think about it. Opposite would be the same as hypotenuse, right? So you can't find the sine, cosine, tangent of any of the quadrant angles using right triangles. For these, we use our coordinate points, okay? So if the radius of this circle is 1, then the r is always 1. So on our unit circle, like notice what's happening. I move to the right 1 and put a point. I go up 1, I put a point. I go left 1, I put a point, you go down 1. No matter where I go around this circle, what's the radius? 1. So that's what's called the unit circle. It's always going to have a radius of 1, okay? Now what's going to change as we move around is what the x and y values are.
Isn't every circle a unit circle?
No. A unit circle is a circle with a radius of 1. Yep. So if I go to sine, okay, of 90 degrees, I'm going to do, sine would be the y over the r, yes? So what's the y at 90 degrees? That's my coordinate point, right? What's the y there? It's 1. What's the r there? 1. The good news is with these unit circles, you actually don't have to have the r. Sine is just y. Now cosine is the x over the r. What's the x at 90 degrees? 0. What's the r? 1. The cosine is just 0, which is the x coordinate. The tangent is y over x. You have a question, Madeline?
Yeah, so the r is always just going to be 1.
For a unit circle. So not the ones we just did. The ones we just did, we moved beyond the radius of 1. But for these quadrant angles, yes, it will always be 1. All right, y over x. What's the y at 90? 1. What's the x? 0. What happens when you divide 1 by 0 or anything by 0? It's undefined.
How do you know, like,
You sure?
yeah, because I was like, how did you know, like, to keep looking at the 90, but then I realized that it says
It's yeah. We'll switch in a minute because we'll do the other one.
yeah.
Okay, now cosecant is the reciprocal of which one? Sine. What happens if I flip 1 over 1? It's still 1. Okay, secant is the reciprocal of cosine. What happens when I flip 0 over 1? Undefined. And cotangent is the reciprocal of tangent. When I flip 1 over 0, I get 0. Okay, so now let's see if we can do it a little bit faster because we don't need the radius anymore.
Why?
Because my unit circle is going to be 1, so my radius is always going to be 1. Right?
So, I don't know how you know, like, that you
So if it acts, this will become your standard circle. But if you don't see it, then you look at the end points all the way around. How far did I go out in each direction? I went 1. And that makes my radius 1, right? And then if that's the case, I mean, I could keep putting it over 1, but I don't need to.
Because then that'll just be.
It goes away, right? Anything over 1 is
But
just.
for the last one, it was like you put it over 0.
Tangent's different. So sine and cosine both go over r. Tangent goes y over
For
x.
the tangent, you're gonna need to put.
Yep. So sine we said is y over r, but r is 1. So sine is really just y. Cosine is really just x. Does that make sense? Tangent is y over x. That one still gets the x and the y. So what's the coordinate point at 180 degrees?
0 for y.
The y is 0. Good. Negative 1, 0. So the 0 is the y. The cosine is the x, which would be negative 1. The tangent is the y over the x. 0 over negative 1, which is?
Oh,
0. Good. You with me so far? So now what happens if I flip the 0?
Oh,
Undefined. Good. So cosecant would be undefined. What's the reciprocal of negative 1? Negative 1. What's the reciprocal of 0? Undefined. So you should also be able to do this for 270, and this doubles back. Remember, it's either 0 or it's 360.
Wait, why is the cosecant undefined?
Because this would be 0 over 1 technically, right? And then when you flip that, it's 1 over 0. I promise you'll get more practice on the circles, and I promise it will get easier.
Wait, but why is the last one undefined? I don't get it.
Because it's 0 over negative 1, right? So what's the reciprocal of that? Negative 1 over 0. Right? The reciprocal of 0 is always going to be undefined. Question so far? So this is different from what we just did because this is now stuck on this circle with a radius of 1, whereas what we just did had you drew out your lengths were bigger than 1 and 1. Okay? So that's why these look different. All right, so these are called your reciprocal identities, and this kind of leads into what we were saying, like if we had to use the calculator, how could we do that? The sine is 1 over cosecant, and cosecant is 1 over sine. So these, remember, they go together, cosecant and sine. And if you're ever confused, the letters never match. So cosine does not go with cosecant. Those would be 2 C's, okay? And sine doesn't go with secant. Those would be 2 S's. It's the reverse. So sine, the S goes with the C, and the C goes with the S. The sine goes with the cosecant. The cosine goes with the secant. And then tangent and cotangent, like cotangent literally has the word tangent in it. So hopefully we know that one, okay? It's, to me, I think that people mess up the other ones. So if I was to ask you to find one of these and you got the other one, they're basically just the reciprocals of each other. But if you're going to use the calculator, let's say, to find something that's the cosecant, your calculator does not have a cosecant button. You would have to do 1 divided by sine of that angle. So if I wanted to find cosecant of 30 degrees, then in the calculator I would have to do 1 divided by the sine of 30 degrees. And I'd get the same thing. So by the time we're done with this chapter, you're going to learn a lot of different types of identities. These are called the reciprocal identities. And really you just need to remember that which pairs match up. So sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. And these are interchangeable, so I could go either way with that. All right, so this says, find the cosine of theta if the secant is 5 over 3. What's the relationship between cosine and secant? They're reciprocals. So if secant is 5 over 3, what's cosine? 3 over 5. Find the sign if the cosecant is negative square root 6 over 2. What's the relationship between sine and cosecant? They're reciprocals, so I just have to flip this. Negative 2 over square root 6. Can I leave it like that? Nope, we have to rationalize. So we multiply the top and the bottom by the square root 6. And I get negative 2 root 6 over 6. And that reduces to negative root 6 over 3. Still good? All right, these are some additional identities. So the first one just says solution intervals, okay? And this says that sine is in between negative 1 and 1. Cosine is in between negative 1 and 1. Secant can either be less than or equal to negative 1 or greater than or equal to 1. And cosecant can be less than or equal to negative 1 or greater than or equal to positive 1. Tangent and cotangent can have any value. So basically, as you set up all these different types of problems, sine and cosine have to be in between negative 1 and 1. So the sine of no angle can be bigger than 1 or less than negative 1. Same for cosine, okay? I can't say the cosine of theta is 2. It's impossible. I'm basically saying that the hypotenuse is smaller than the adjacent side, but we know the hypotenuse has to be the biggest, right? So it's impossible, okay? So this row basically just means that cosine and sine can't be bigger than 1 or less than negative 1. And then because that's true, the reciprocal functions would be the opposites. Secant and cosecant have to be outside of negative 1 to positive 1. Because if I flip these, right, then these can't be.
Wait, you said can't be bigger than
Than 1.
Oh.
Yeah, no, it's okay. This is just basic. You'll find that your calculator would give you like an error if you had something like that. Like if it said to find the angle where the cosine is 2, you can't do it. So you'll find these out by working out questions. You won't really have to know that. Does that make sense?
Is that just a 4 next to the, wait, oh, they're totally wrong.
So these can't be bigger than 1 or less than negative 1. Because then you're saying the hypotenuse is smaller than the adjacent side, or the hypotenuse is smaller than the opposite side. And the hypotenuse has to be the biggest side. Does that make sense? And then when I flip those, sine and cosine, I would get these reciprocals. And so this is the opposite. They can't be in between negative 1 and 1. They have to either be smaller than negative 1 or they have to be bigger than positive 1. And then tangent and cotangent, it doesn't matter. There's no restriction on those values.
Why is there no restriction?
Because there's nothing that says the adjacent side has to be bigger than the opposite side, right? Those could be whatever you want. Because tangent's adjacent over opposite or opposite over adjacent for cotangent, right? So it doesn't matter. If opposite's bigger than adjacent, it's fine. And if adjacent's bigger than opposite, it's fine, right? All right.
Sorry, what is that saying?
It says it can't be less than or equal to negative 1 or, no, it can't be in between negative 1 and 1. Sorry. That's how my brain wrote it. You want me to write that in words? It cannot be between. Can't be in between negative 1 and 1. And it can't include negative 1 and 1 either. But again, like you're not going to use those to work something out. You would get something that has an error that you can't find, and that would be why it happens. It's more important to know these, like this is called Pythagorean identities. These three we need to memorize. And I'll teach you a trick to memorizing. Maybe I'll start with that tomorrow. Okay, I'll teach you a trick to memorizing them. But for right now, you want to know that sine squared plus cosine squared equals 1. You want to know that tangent squared plus 1 equals secant squared. And you want to know that 1 plus cotangent squared equals cosecant squared. This is if you're building a reference sheet for chapter 5, you're going to definitely have that, okay? I would have like SOHCAHTOA, I would have the y's over the r's, and I would have this. And then the quotient identities you also want to have memorized, and that is that tangent equals sine over cosine, and cotangent equals cosine over sine. So those, like, we will use the name Pythagorean identities a lot, not so much quotient identities. I'll ask you sometimes, like, what's tangent? And you'll tell me it's sine over cosine. I don't really call it quotient identity. But the Pythagorean identities we'll call by name a lot. All right, we're going to try one of this and then we'll stop for the day. And that is this. Use the Pythagorean identities to find the following. So we just said that the identities are sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. So those are the three Pythagorean identities. Number 5 says find sine of theta and cosine of theta if the tangent of theta is 4/3 and theta is in the third quadrant. So for me, I need to draw it out. I need some visuals. That's how my brain works. Doesn't mean that's how your brain has to work, but let's just try it. If I know I have an angle in the third quadrant, where does it go? This one, here to here, yes? That's an angle in the third quadrant.
Why is it not a triangle?
Well, I could do this. Okay, so that meant I moved left, my x had to be negative. I moved down, my y had to be negative. Right? But my tangent is positive, a positive 4/3. Is that wrong? I mean, I could have had a typo, but I didn't this time. Is there another way that I could get a positive, but them both be negative? If I put a negative over negative, what happens? It's positive. So even though I'm in the third quadrant, would my tangent be positive? Yes. So this, remember 4/3, is my tangent, and my tangent is y over x.
Didn't we do this problem?
You did it with a coordinate point. Yep, it's the same exact thing. So this is 4. Nope. This is 4, and this is 3. You just have to know that if it's in the third quadrant, I have to make them both negative.
Wait a minute, wait.
Tangent is y over x, right? But it's in the third quadrant, which means it has to be negative for both of them. What's my radius? 5. So what's my sine? How do I get sine? There's two ways, remember? Negative 4 over 5. I can either do y over r, yes, or I could do opposite over hypotenuse. Either way, negative 4/5. Sorry, no. And then cosine would be what? Negative 3/5. So a lot of times when we get to trig, it's like looks like it's a completely different problem. It's the same kind of problem, just in different words. Okay, next one says find cosecant if cotangent is negative 1/2 and theta is in the fourth quadrant. So now I'm in the fourth quadrant, which means I move to the right and down. My x has to be positive, but my y has to be negative. Now if cotangent is negative 1/2, that means tangent would be what? Negative 2, technically negative 2 over 1, right? And that is your y and your x. So the y is the negative 2 and the x is the 1. Is there a triple 1, 2, and something else?
Does that say COT?
Cotangent, yeah.
How'd you know that was the cotangent?
It's in here.
Oh, okay.
Yeah. I just flipped it, which you could have done x over y. Like I could say that this is x over y. I tend to just make it in terms of tangent. I flip it, but you could do either one. There's no triple with 1, 2, and something, which means I have to do 1 squared plus negative 2 squared equals the radius squared. 1 plus 4. R squared equals 5, and r would equal the square root of 5. Technically, it's plus and minus square root of 5, but remember, radius is always positive. So what's the cosecant here? Cosecant's the reciprocal of what? Sine. So if sine is y over r, then cosecant is r over y. R is the radius, which is the square root of 5, and the y is negative 2. So go ahead.
I'm confused. How do you know what you're looking for?
It asks it here. Find.
Oh.
Yep. It starts with it. So it says to find that if you're given what you're given. So I'm going to stop here and I'll tell you where to go on the homework. I would at least attempt it. It's not due tomorrow. I think I made it due Thursday so that we can finish it. Let me tell you. And remember, these are PDFs. I put all of chapter 5 at the top of the module so that if you need reference and you want to use your textbook, you can. You can get to so you got to kind of jump around. You can do the first, I'll write it in there, but 3 through 9. So I'm going to put day 1, 3 through 9. I should have opened it here.